Okay, on the first example, we're going to look at how to graph this rational function. First thing we want to look at is that x plus 3 over x plus 3. This is going to give us a whole at x equals negative 3, and I usually do that last. So we want to try to remember that. So no matter where our graph is, our very last step is going to be, just erase it a little bit, just put a hole in it. So if we ignore this part, save it for last, now we only have two things. Whatever makes the bottom 0, it's going to be a vertical asymptote, so x equals negative 2 would make the bottom 0. So our vertical asymptote is going to be at negative 2. Whatever makes the top 0 is just a 0 or an x-intercept. That happens at 1. And the y-intercept is going to be whatever you get when you plug a 0 for x. So after I plug a 0 for x, I'm going to get negative 1 squared. Negative 1 squared is just 1. And the bottom is going to give me a 2. So the y-intercept is just going to be 1/2. Okay, now we can go ahead and graph our function. We know for sure that these 2 points are going to connect. We know it doesn't go down because then it would be another x-intercept. That can't happen. So it has to go up. And it's just going to approach the asymptote. Now the graph could turn around or it could cross through. And that all depends on the power of the 0. Because our 0 is squared, it's going to touch and turn around. Now this function had no horizontal asymptote because the degree on the top was bigger than the degree on the bottom. So the graph is just going to go towards infinity on the right. Now for this vertical asymptote, the degree was 1, which is an odd power. So odd power means one side is going to go up and the other side is going to go down. Now we know it can't cross through because the only x-intercept was at x equals 1. So it's just going to have to turn around. And again, there's no horizontal asymptote, so it's going to head towards negative infinity on that side. Now don't forget the hole from the very beginning. When x equals negative 3, you have a hole. So we put a hole in our graph at x equals negative 3. Now this is just a basic sketch. Not every single point is accurate. But if you wanted to get it more accurate, just plot more points. Okay, for this one we can see that the vertical asymptote happens at x equals 1. And that's because x equals 1 makes the bottom 0. We can also see that negative 2 and positive 3 make the top 0. So those are going to be x-intercepts. Now the y-intercept is whatever you get when you plug in a 0 for the x. So we get negative 6 for our y-intercept. So I'm going to have to go by 3's on my y-axis, or else I'll be off my graph paper. To figure out the horizontal asymptote, we just want to multiply everything out and look at the biggest power. Here you can see that x squared is the biggest power on top and x squared is the biggest power on the bottom. So now we just look at the leading coefficients. They both have a leading coefficient of 1, so that's going to be your horizontal asymptote, y equals 1 over 1. Okay, now we're ready to draw our graph. We know that these two dots connect, and for this x-intercept, the degree is 1, so we know it crosses through. Then it's going to approach the horizontal asymptote. Again, the graph cannot come back down because that would create a new x-intercept, and there are only two x-intercepts. Similarly over here, it cannot go up and cross through because again, it would create a new x-intercept, and again, we only have these two x-intercepts. So it must go down and it's going to approach the vertical asymptote. Now because this vertical asymptote is squared, the graph will do the same thing on both sides of the vertical asymptote. So if the left side goes down, then the right side will also go down. Again, at this x-intercept, it could cross through or it could touch and turn around. It just depends on the power. For this x-intercept, the degree is 1, so it's going to cross through. Any odd power crosses through, any even power turns around. Now after crossing through, it can't go down because that would create a new x-intercept. So what it's going to have to do is just approach the horizontal asymptote. Okay, the whole idea of homework number 9 is basically just to be able to graph all these functions. So again, this part right here is going to be a hole when x is negative 1. We usually do that last. So I'm just going to kind of cross it out for now, but try to remember that we have a hole when x is negative 1. Now I want you to notice that there's a vertical asymptote when x is negative 2, and I've already graphed it right here. Also, there's an x-intercept when x is negative 5. The y-intercept happens when x is 0, and that would give you 5/2 or 2.5. Now because this is the only x-intercept, we know that it cannot go down right here. So the only option would be to go up and approach the vertical asymptote. Again, we can't go down because that would create a new x-intercept. So we're going to have to just approach the horizontal asymptote. Now the degree on our vertical asymptote was just 1. So that means if one side goes up, the other side is going to have to go down. When we get to this x-intercept, we can see that the degree on it is 1, so we know we're going to go through it. And then we're just going to approach the horizontal asymptote. And again, the reason for that is that we know we can't go back down. It would create a new x-intercept. Okay, we don't want to forget our hole when x is -1. So let's put our hole when x is -1. Remember, this is just a sketch. If you want it to be more accurate, you just need to plot more points. Okay, now that we've graphed it, we can go ahead and answer the question about continuity. It says if this function was made to be continuous at x equals -1, then what would have to be the value of f of -1? Right now, f of -1 does not exist because there's no point when x is -1. We actually have a hole in the graph. So if there was no hole, meaning if we removed all this, what height would that point have to be when x is -1? And you just have to plug a -1 in. And if there was no hole, you would get 4 for the height. Now that I know the height is 4, I can adjust my graph to be more accurate. I also don't want a hole in my graph anymore, so I can adjust my picture to be a little bit more accurate. But the answer to this question would be 4. F of -1 would have to equal 4 in order to fill in the hole. Okay, here's a tough one, piecewise functions. When x is less than 2, it's going to be this function. So that means everywhere over here. When x is between 2 and 4, it's this function. So that means in here. And when x is greater than or equal to 4, it's this function right here. So that would be in this region here. Okay, if we're going to graph this function when x is less than 2, then let's start when x is 2. If I was to plug a 2 into that function, I would get -1. So that'll be a point, 2, -1. It's going to have to be an empty circle because we do not include the endpoint. Now we can plot some more points. When x is 0, you get 3. When x is 1, you get 2. We can copy these other points onto the other side. And just draw it the best you can. Now for the middle part, when x is between 2 and 4, it's going to be 6 minus 2x. I think most people recognize that as a line, so we really just need 2 points. And the best points to choose are just the endpoints. So when x is 2, you see you'll get 2. You can plot that point. And when x is 4, we get -2. Okay, the last part we're going to look at is when x is greater than or equal to 4. Again, it's just another line. We always want to plug in the endpoint, so we're going to plug a 4 into that function. 4 minus 6 gives us -2. So we got the same value as the other function, so it kind of fills in the hole. Now if I plug in a 6, I get 0, so that's another point. For a line, all we need is 2 points, and we can connect the dots. And this is how you would graph this piecewise function.